relatively real time, right? But what is a real time? Like at which point the user would get annoyed that the the system is a bit broken. What would be the kind of the threshold? A minute? Yeah?
Yeah, I'd say roughly a minute.
30 seconds maybe? Depends on how anxious people are, right? But it's kind of, yeah, like something between 30 seconds and a minute is sort of a user scale kind of asynchronous communication interactivity level where you say, yeah, it's like I can wait 30 seconds for this. If you told me the email was sent, I kind of expected within a minute to show up, right? If it shows up immediately, that's fine. But if it shows up like, in a minute, it's acceptable. If I have to wait half an hour, I wonder like, okay, somehow things get a bit messed up, right? So let's say we did set it up for a minute, which means 60 requests per hour, which means 24 times 60 a day and 30 days a month. We're doing a lot of requests, right? Do we really need to do all those requests all the time? Well, we can use a trick, right? We can see, is the app active? Is the user actually looking at the Gmail client? If there is, we will be checking every 15 seconds. If they are not looking at Gmail, we will check every hour or every 4 hours, right? And then notify them, oh yeah, you got an email, right? It's obviously they are not really expecting anything right now, because if they were, they would probably open the app, right? Yep.
If you Google, you also have some info about like when is the device active, so you can make a guess as to when the user sleeps.
Exactly. That's right. Exactly. So you can do some tricks. As a programmer, you have kind of options to do that, right? If you leave that choice to the user and you want to tell them, okay, when I'm sleeping, I don't need to see the emails. If I'm not sleeping and I'm at work, okay, once an hour is fine. If I'm like in the afternoon chatting with others, I want every 15 seconds. The setup is like way too complicated for the users to really set it up, right? So some of those decisions, like as you said, I never seen this. Well, you've never seen this because it's kind of a bit archaic. We don't do that this way, right? Okay, anyway, so we have set it up every 15 seconds, right? There is a particular threshold, like, at some point, it doesn't make sense to open the connection, check stuff, close the connection, and open the connection again, and so on, right? If you're doing things too frequently, it's actually better just to open the connection and keep it open for the duration of the things, right? So I don't know how Gmail exactly works, but I suspect when you open Gmail client, they will open the connection to Google if you have network alive, and they will keep it alive during the duration of you interacting with the app. So if there is an email coming to your account, it will be immediate, right? Because the connection is actually kept open. It makes more sense to keep it open when the frequency of the updates is too big, right? So for example, if you have any app that tracks like stock market or tickers for the currencies, they will open the connection and they will keep it open while you're interacting with the app, because it makes no sense for you to be doing very frequent checks. So that you as a developer, you set a particular threshold at which it kind of makes no sense to use the open close pattern instead of just open and keep it open. All right, so I will move here a little bit so I see the screen. So today what we will discuss is we have 2 parts to the lecture. One is a little bit generic about the platform, about Android platform. And because I talk a lot and I always run out of time, I will start with the second part. And the second part is about the Android Studio and about programming for Android. Tomorrow, we will have a practical session where you will actually do some simple things with this. Today, I'm going to tell you a theory, right? So those are 2 parts, kind of a general overview of the platform and the more specific overview of the components which are used for programming on Android and why we have that this way, right? So I will start with this, and we see how far we get, and then the other part you can watch from last year without the interactivity part. The other part is a little bit more easy to read about on your own. The second part, I want to tell you a little bit of stories. So what we will do is I will bring the slides. And you can, as I'm saying, I will probably run out of time for the first part, so you can watch it like from last year. It's like not much changed. One comment about the first part, it has quite a lot of slides, and some of the slides are, so it has quite a lot of slides, and some of the slides are going through the history, right? Yeah, you can kind of gloss over it. It's not that important. It's just there to kind of highlight some of the developments that happened. Yeah, you don't really need to read that in detail. What is important is this one, where we see how the platform was developing, right? So I will spend a little bit of time on that. Android has versions as any other software, and the versions are backwards compatible to some extent, and they deprecate some features. And then when manufacturers issue new devices, they kind of release it with a particular version of Android. And then on some devices, the manufacturers keep updating to the later versions. On some devices, they don't. And then after a few years, your devices are a little bit obsolete, right? Why they do that? One way or the other. Kind of depends on the marketing strategy and the business model. So for example, for Google, they want developers to always work with the latest APIs and to bring the software up to date, to be competitive, right? So Google phones always update to the latest one as soon as the latest one is available. And when Google releases a phone with a particular manufacturer, they always target the latest API, right? If you Samsung and you work with Google, then you will do that because Google gives you extra benefits when doing that. But if you, let's say Motorola, and you're not doing that for that year, so each year Google signs a deal with one of the manufacturers. As we told yesterday, Google is not a hardware manufacturer themselves. So Google phones always are either Samsung or Motorola or HTC, right? They cut a deal with one of the bigger manufacturers and they promote their hardware using the Google branding, and they target the latest APIs. And that makes the manufacturer kind of visible to the rest of the world, because that's always the best it's always the best Android phone on the market for that year, because Google tries to make it that way. But if you're not in a particular year with Google, then you may say, I'm gonna target a particular Android version, right? And then what happens is you develop the hardware, you develop the software on the Google platform, and it's out. And people are using it. And the release cycle is roughly a year, right? So then the next year there is a new version, you make an update, but it takes you effort, right? It costs you money to make the update work on your hardware and for your phone. And then the next year there is again an update, and you do that again, and it's again a cost. You don't really have much benefit, right? You don't have more users, you don't have, I mean, you have some new users, but they would buy the original phone anyway, right? With the original software, and then the updates happen. So at some point, the phone is a bit old and people need to buy the new phone. They need to update, right? So then they can buy a new hardware with the new OS, or they could use the old hardware on the OS. So there is like a balancing act of, in particular time, like in 2 or 3 or 4 years, the hardware is so old that it doesn't make sense to have the latest Android on it, right? So that at some point the support has to drop. So historically, that's how it worked, and historically you could track what was the biggest market share of a particular version of Android, because for you as a developer, that's a sweet spot, right? That's your biggest market. So if you're targeting particular APIs, that means that the APIs below it will not work. Like the phones which only have Android lower than your one will not work with your software, and then the higher ones will not really take full advantage of what they have, right? But you have the biggest market share. So in here, like in 2012, Android 233 was the biggest one, right? By far, as you see by the market share. And then in 13, it was more evenly split between those three versions of Android. So the 4, 4.0, 4.1, and 233, right? So 233 shrunk a little bit, and then 4.0 and 4.1 kind of took over. So it was kind of a more evenly split market share. And then in 14, 4 took over by far, right? And so on. And you can see how it kind of looks like. The interesting thing is that in 16 and 17, it was kind of evenly split among roughly 3 or 4 platforms. And then last year, the trend kind of continues. So as you see for the last, let's say from 2015, there is no single version which is like majority of the market. The market kind of got more and more fragmented, right? So as you see for the last year, the biggest is probably Nougat, which is 7.0, which has 18% of the market share, right? But the times where you had this 55 or 80% of the market share for a single OS are gone. Like the market is effectively fragmented. And it's the same for iOS to some extent. All right, so before we talk about the application components, what is the difference between programming for a mobile device and programming for a laptop or for a PC? What are the sort of the factors that you would say are differentiating? Yeah.
More energy efficient because the laptop more output has more electricity and then more powerful hardware, so it would be more efficient on the phone.
Of course. So one aspect is power, right? Your laptop, I mean, with laptops, yeah, you kind of think about the power efficiency to some extent as well. But let's say a PC, right? A PC plugged to a power has unlimited power, right? If you have to do something in a loop, you just do something in a loop and you just burn energy, right? You cannot do that on the mobile. Anytime you're doing it, you're wasting the battery, and the app will drain the battery, and it will be not popular app. Like people will hate it, right? So the first rule is do nothing. Like if you can do nothing in your app, right? Show users something and then do nothing. Your app should spend most of the time actually doing nothing, right? So you have to plan how to do nothing, right? So that's one aspect. What else? Yeah.
The input, our users input because on the corner you're not using the thumbs.
Yeah.
So you probably don't want to have something that is very high. And also how you design your app.
Yeah.
Because you need like big buttons that are easy to press, because if it's too small, people are going to
yeah. Okay. So in like the modes of interacting with the apps and the user interface, right? So that's another one. They have to be tailored for the mobile device. They are different on a PC, different on the laptop with the touch screen, and different for the mobile, right? What else? Yeah.
And related to that, you're not getting around designing some kind of GUI. Like in what we've made so far in the course, some time I at least have just made a text-based interface.
Yeah.
It's a lot easier.
Yeah.
But on mobile, you can't really do that.
No, you really cannot have a text-based interfaces on mobile, right? For the second reason that you mentioned, right? Yeah. That's right. And you have limited real estate, right? On a PC and on the laptop, you have quite a large amount of pixels and space to have GUI elements presented. On some of the early mobile phones, like we have some devices which were which had a very small, yeah, those are all reasonably, good. But you may have a kind of a small factor device which has very small resolution, and you can only have like 200 by 300 space on it, or 160 by 240, right? In which case your amount of screen real estate is very limited. So you have to deal with that. So we have one aspect is the battery life, the model for programming. The second one is the limited real estate, and the third one is the way that people interact with the app, right? So one way that it never works is kind of text-based interfaces. It's really hard to do. Typing text is also quite hard. Of course, sometimes it's unavoidable, but then usually it occupies most of the screen. You have the keyboard, virtual keyboard, and a little tiny text field, especially if you're doing it like horizontally, and then nothing else can be visible, right? So we do use sensors, and we do use various ways of interacting with the app, and we rely on the graphical interface heavily to kind of interact with the user, right? So the way we structure the mobile application kind of changed over the years, and iOS is doing things very similarly, but slightly differently. Both platforms use this kind of a model view component perspective to organize the way the development of the app actually happens. So we have to manage the life cycle for the various things that happen, and the operating system has to do that to conserve battery and to kind of make the apps kind of nicely work with each other, right? There is one extra element which is slightly different to the way PC works versus the way mobile works. So if you have a laptop, you typically have multiple apps which you can run, okay? So what happens if I have two apps that try to access the same file? Is it okay? Can I run two apps that access the same file on a PC? Yeah, of course. Can I have one app which accesses the binary of another app that I have on my PC? Yeah, you know, if you have access to it, the app which you run has access to it, right? So what will happen if one app messes up with the binary of your on your PC with another app? You have a problem, right? And that is the problem that we typically have. So the problem that we typically have is we have a user-based permission system which allows the apps to do what you can do as a user, right? Fine. Can apps do something that you cannot do? Can you run an app which can do something you cannot do on your own PC, given that you have administrative privileges and everything on your PC? That's right. So anything an app which you run can do, you can do yourself. It may, as you say, it may be a little bit more cumbersome. The app might be you know doing it like in a simpler way, but you can technically achieve everything the app can do yourself, right? On the mobile phone, that's not true in general for historical reasons. So if you have a mobile phone, the mobile phone can, for example, dial an operator like internally, like when like you can pick the number, so you doing that, right? But you only picking up the number. It's the software and the modules which actually connect you to the operator and to do all the handshakes and all those things. You have no control of how this is done and how that works, right? You cannot change it, you cannot manipulate it, you cannot, you know, fiddle with this. It's like isolated and you have no access to it. You can pick the number, you can initiate it, and then what actually happens, it's out of the control of the user, right? And it's the same in the mobile apps. So sometimes if you don't root your phone, you don't have a root privileges, and if you don't have root privileges on your PC, it's the same. Like some things can be done because they have kind of an elevated privilege model, and some things you cannot achieve yourself. So as a developer, it's kind of nice because you have an ability to separate it. You can have things that you can do as a developer and the app can do, but the user has no access to it, right? Because they don't have the root privileges. So to manage all this complexity, as I was saying, organically, we developed kind of a way of thinking about it. And in Android, it's relatively straightforward. You have 4 main components. One is called activity. Second one is called service. You have content providers and broadcast receivers. Those are 4 main application components that you will be using to develop your apps. And why we have them, it will kind of become clearer as we discuss. So what is the first thing that you interact with? You pick the phone. Yeah, I left my phone. So imagine that I have a phone. And on the screen, there is a kind of a stuff that you interact with, right? So let's talk about a Gmail app. You have, let's say, your inbox with the emails in a list, right? If you click on the particular email, that list disappears and you have presented a screen where you have that particular email, right? And then you can go back to the list or you can select the new email, right? So I have always kind of a one thing which I'm interacting with, which is like a part of my app. On a PC, typically what you have is like you have kind of the bigger interface which you interact with various aspects of what this app is doing. But on the mobile device, because of the limited real estate, you have to split this more rich kind of interaction environment into individual screens, so to speak, right? So an activity is effectively a single kind of abstract concept which represents a single screen that you're interacting with, right? So it always has a visible element because it's about the screen and about interactivity, and it's always about a single thing, single activity, and that's why it's called activity, right? So you may have something which doesn't have a visual element and it runs in the background, and that's basically a service. So the life cycle of the activity and the life cycle of the service are similar. The difference is that the service doesn't have a visual element, and activity has, right? So I will talk a little bit about the other two later. So an activity represents a single screen of the user interface. And in Android, we have a class called activity, and your particular activity will subclass that class. So we're using object-oriented concepts, and we are inheriting from the activity class, and we're calling it, I don't know, email list activity or something like this. We usually append the activity at the end to make it easier to communicate that this is an activity, and it will kind of be one thing that the user interacts with, right? So for example, activity 1 can be like a show of list of emails. Activity 2 will be the editor for writing a single email and pressing send. And activity 3 might be like a viewer for browsing, like viewing a single email, right? And now you have 3 activities, right? So each activity is independent of each other, and it kind of occupies the entire interaction mode, right? So when you boot your Android, the very first, and you unlock your screen, the thing that you see is called home screen. And that is an activity which manages the icons and manages all the apps that you can launch, right? It's exactly the same. It's implemented as a home activity, and it basically has a big display with icons on it and some buttons on top and on the bottom, which allow you to interact with some of the system functionality to launch other activities, right? There is no difference between the activities you write and the system activities that we have. And then any application can start any activity. You can start from your own home, like main activity. You can start other activities, or you can start system activities, as long as you have the correct permissions to do that. So you can start Gmail, you can start, Google Maps, you can start whatever user has installed from within your own app, and it will kind of seamlessly integrate with the activity. So example here is using camera. You can use a camera to launch a new activity. So what happened was, historically, we have this model of the activity being one single thing. And then we realized if you have a tablet, you now have a little bit more real estate, and you could potentially have two activities visible at the same time, right? So you can see here with the email application, we have three activities. And this one are related to each other, because the list shows you the list of the emails. And when you click and select an item, you see a particular email, right? So on the normal phone, there is not enough real estate to put both together. But if you use a tablet, you could have a list of emails, and then if you select one, you see the email details, you know, on the right panel, right? So, you know, before version 3 of Android, we only had activities like this, and we couldn't do this. This would have to be a fourth activity, which combines list and the viewer for the email, right? And it's a bit of a nonsense because we already have those two subcomponents. So we should reuse what we already have to create this, right? So it was kind of interesting. Up to version 3, you couldn't do this. I mean, you could do this, but you have to re-implement this from scratch. And this was the default. So version 3 was introducing a concept called fragments. Because as you see, we still have a single activity here, but this single activity is composed of two independent visual elements, right? And now we separate it. Originally, the activity and the visual elements were together, were glued together. From version 3 onwards, we said, okay, it actually makes more sense to treat them sometimes as isolated elements, and then we can compose a single activity having more than one visual component inside. And those visual components are called fragments. So the concept of activity remains. We can only have one visible activity at the time. You cannot have more than one visible activity at the time on Android, ever. Nobody can. Even the operating system always has one single activity visible at the time. But that single activity can be composed of more than one visual representation. And those visual representations are called fragments. What if you're programming for the mobile phone? Yeah?
It's not how this fragments, how the like Facebook Messenger app works, because that overlays something over your app, and you kind of have them.
Yeah. So fragments can overlay each other, right? Fragments can overlay each other, and fragments can be like modal dialog boxes. So something can be on top, like asking you, like a dialog box. But that's just fragment. It's not an activity in itself, right? You can only have like one activity at a time. So before, when you said my activity extends activity, it had all the UI kind of machinery already in the class to deal with the representation of the UI, right? When we decided to split it, now you would have to say, my activity uses this fragment, and then you manages the fragment and manages the lifecycle of the activity. For activities that only have one fragment, it's a little bit of nuisance. So what there is a class called Fragment Activity, which means there is one default fragment for that one particular activity, and it works as old model, right? Because you will have something like this or something like this, right? But a fragment activity cannot reuse the internal fragment in other activities, right? So you only do that in a situation where you always occupy the entire visual screen of the user. So for example, if you want to have a list, which is always a list, and it's always a single list on the screen, no matter whether it's a phone or tablet, then you can use a fragment activity to represent that, right? Because you don't want to be reusing the list in some other layout of the screen where you have more space, right? But if you have something reusable, like in this case, if I have an email list, it makes sense to just have a list, or it makes sense to reuse it for an activity which has email list and the email details at the same time, right? In which case you have to declare that you have an activity, and this activity will check which orientation of the phone is and what fragments it should manage, right? So you have like a fragment manager which manages for a particular activity what fragments are visible and which are not visible, right? So conceptually, it is getting a little bit more complicated than it used to be, and you have to now manage two classes. One is the activity, which is the abstract representation of what the user interacts with, and then the fragments, which is the actual visual representation of what the user interacts with directly, like what is visually on the screen. Does it make sense? Okay. And then there is this one fragment activity, which is like a shortcut for doing both at the same time in an easier fashion, right? Because then you don't need to deal with the fragment manager because it's kind of done for you. Right. So what is the life cycle of an activity? Well, an activity is first declared, so it's like a class, and then you don't say new. Like in normal Java, if I declare a type, let's say I declare a type person, then I have to have a variable which in the tutorial was called p equals new person, right? In Android, for all the activities and the life cycle of the services and activities, we don't do that. We let the operating system manage that for us. It often is the case with game programming as well. And it's sometimes the case with some frameworks where you're not allowed to create objects yourself. You are using a pool and you say, give me a next object of that type, and the pool manages the memory allocations and the creations of the objects for you, right? So we don't want to give the user, the developer, the management of memory for all the activities. We want the operating system to do that for us because they know how many threads are already allocated, how many times the user already clicked on the Gmail app. Maybe they've already have it and it's like in the background right now, so we just need to bring it back. So the life cycle is kind of managed by Android. We don't say new, we don't say activity A equals new activity. It kind of happens behind the scenes, yeah?
In Android Studio, is it possible to log which one starts and which one stops when you use or open up?
Exactly. So you get the callbacks through those methods, right? So when the user clicks on your app icon and your main activity, let's say it's called main activity, you will get a notification, which is basically a call to onCreate on your method. And then you know, okay, somebody is actually creating my object. And you can do all the additional memory allocations and everything to do with the state of your app, like what you manage and so on, right? So if you, for example, manage people and you have a class person, of course you will say p equals new person inside your activity, but you don't create activity by new. It happens for you and you get called. And those methods are calls that operating system calls on you when things happen, right? So when the user launches an app and it hasn't been launched before, then you have onCreate. Then onStart happens, and then after onStart, the app is on the screen. The user is like seeing the app, right? So onCreate happens before the user is shown the app, and onStart happens when the user for the first time see the app. And then when the user clicks back button and see the home screen, then onPause happens. And then when the user kind of clicks the icon again, onResume happens. So it is also onResume happens on the very first go through the sequence as well, right? So the sequence is the user clicks, launch me this app, onCreate happens first, and onCreate happens only once, right? OnStart happens second time, next, and it also happens once. And then onResume happens. And then the user sees the app. If the user presses back button and the app disappears and the user sees home screen, the onPause happens. And then when the user says, okay, bring me that app back, or if they click again on the launcher, then on resume is called and you back with the app, right? Those things happen automatically, and if the user kills the app, then on stop happens, right? So you as a developer will know that the user wants to kill the app, and then you can back everything up. And then on destroy, you have no control, and the user has no control neither unless they go into this app manager app and say force quit, right? Then hopefully this happens, but this is up to the operating system to do that, right? It's only the operating system which actually makes the final decision whether to call this method or not, right? This one is a little bit up to the user. This one is not, right? But you can force close, and then hopefully this actually happens, right? What should you use this one for? Generally, you don't use it for anything, right? Because you never know when it is called, and you do all your backing up and all your state saving in this method, right? So all your, like, if you want to back something up or if you want to record something like the partial state of the app, you do that in onStop. And then it is possible to go back again from onStop through onRestart to onStart, right? It is possible that the user kind of, or the operating system actually trash the app, but the user wants the app back. And then what will happen is onRestart will be called and onStart will be called and onResume, and then the app is running again. So, well, it is a little bit complex, but you don't have to implement all those methods. You basically implement them by override the methods which we have. And which methods do you need to override? You usually override onCreate because you want to allocate, resources, and you need to prepare the app to actually do whatever it needs to do. So you almost always override onCreate. And then you almost always override onResume and onPause because you want to know when the user sees the app and when the user is not visible, and when the user sees the app and when the app is not visible, right? You typically do the backing up in those, like backing up and onPause and restoring the state and onResume, right? That's it. If you're playing a game or if you're doing a lot of backing up, right? If it's like, time consuming and energy consuming to save the state, then you don't really want to be doing it all the time and on pause, right? You want to retain the state in memory and dump it to persistent storage or dump it over the network only when you know the app is gonna potentially disappear. So in that case, you will do this long backing up in onStop instead of onPause, right? Yeah.
When I was researching for the activity cycle, I also found two more states, which was the on-restore instance state and the on-save instance state.
Yeah.
Which I have to use in order for the app to not close when you click.
Yeah, that's right. Yeah. This is on-restore instance state. Is additional callback which happens when you change the orientation of the phone. It is not part of the normal life cycle of the app. So if the user never flips the phone, or if in your manifest file, if you said the app can only be used in portrait, it doesn't matter if the user flips the phone, then the other calls will never happen, right? So they kind of happen when the activity is trashed by the user, or if the orientation changes, and if you want to restore and store the state because of the orientation change. So you can store the state using those two methods and restore it, or you could use onResume and onPause, right? So yeah, it's a little bit, typically what happens is if the app changes the orientation, you use those two methods to store and restore the state. If the app normal life cycle happens, you use those two methods to do that, right? There is subtle difference between the usage of those two mechanisms, and most developers will, for normal things, use those two. For the orientation, would use those two. And for those, you use something like properly persistent, like you use like the file storage or your properties or the network. For the other one, you do a little bit of a hack, because the other one is always like a temporary, right? So like storing and restoring is kind of time bound. It's always a little bit more ad hoc, more temporary. You just flip the phone, or you kind of close the activity and it kind of restarts immediately, right? With those ones, you kind of do it a little bit more heavy duty, more properly. But they basically do the same function, yeah. What was, you had a question as well? Okay. All right. So then we have services. How are we doing with time? Right. So let's have a 10 minutes break, and we will come back to talk about the services and the other components after the break. Okay. So did I say 10 minutes? I guess. All right, so let's continue. So just before we move to services, I want to get you a little bit of a feel of what it means. Like this chart is kind of nice visual, but what it practically means. Well, it practically means, as we were discussing, that you have to implement those methods, right? So here I have, yeah, so I'm extending kind of an activity, but as I said, what was the class name did I say that you have to extend? Activity. So why I am extending up compat activity, not activity? Yeah, why would I do that? Okay, so normally if I were targeting the latest API, I would do extend activity, and I don't care about the previous versions of Android, right? But activity has grew, like from the original Android, the class activity has introduced new and new functionalities. For example, an action bar, for example, some kind of facilities that a screen as an activity has, right? Like the fragment manager, as we were discussing, like in the past, there was no fragments, right? So if I were to target a very modern Android application, I would just extend activity and it would work on the latest API, right? All the facilities would be there, but it wouldn't run on the older phones. So if I want my app to have all the modern facilities, but also work on the older phones, what Google engineers did, they created a library which pretends to have all the new stuff on the older phones, right? So you can have an old phone which runs old Android, but it has a mocked taskbar and the action bar and the icons and things like this, which were introduced later, and they appear as if they work natively on the old Android, and it's called Compatibility Library, right? So it's a library which allows developers to target later APIs, but still have it working on the older phones. But to do that, you have to extend this application compatibility library things. So instead of extending activity, you have to extend app compat. And as you see, it's packaged up into version 7 of the compatibility library that I'm using in this particular example. And this kind of tells you what version of the compatibility library I'm targeting. And then I'm extending this. So then my class is an activity. It has some private fields. And then I have this protected on create method, which I'm extending. And it takes kind of a saved instance state as a bundle. That's what the discussion which we just had here of you can store temporary state in the bundle. And the bundle is basically like a structured key value pair thing, where the keys are strings and the values are objects of some type. And then you can store things in the bundle, and then the bundle is passed around as a bundle. That's why it's called bundle. So I can save some state into the bundle, and then I can restore it from the bundle that is passed into my method here. Okay, is it big enough? Or yeah, can make it a little bit bigger. So you know why this activity is app compat, and should those methods be public, or do they shouldn't be public? They shouldn't be public because nobody else should be calling them. It's the framework which will be calling them, like the internal operating system framework, and nobody should kind of see them from outside, right? So then why they are not private? Yeah.
If I remember correctly, they're private for the entire package. It's just protected everything in the package.
Yeah, that's one very good reason. that they are visible outside the package. So a framework which might be implemented in a different package can still call those methods, right? I mean, they cannot really call those methods, but they can yeah. So from a different package, they are not visible. From within the same package or from the system framework, they can be used. Yeah. Private ones cannot be used, right? They can only be used in that particular type. So then we have this annotation here. So Java has annotations, and they always start with the @ symbol and some keyword. And they are for fields, they can be for methods, and we kind of make use of them. Would that code work if I take it out? Would that code work fine if I don't have this annotation? So if I say, if I comment it out, would that work? Yes, it would work perfectly fine, right? So there is no requirement for you to use the annotations. They are just a convenience for you to achieve something. And what is this annotation achieving? Do you know? Yeah.
It lets us know that we're overriding the onCreate function that we inherited from.
Yeah.
So it's really easy to see that, oh, this is something we're overriding.
Exactly. So one reason is that it communicates to anybody reading the code that this method is not created in this type in main activity. It is actually inherited from a superclass which has this method, and I'm overriding that method here, right? So it serves the purpose of communicating to other developers what actually happens here. If this is missing, it's a little bit hard to remember that this type has onCreate method, right? And now it's obvious, like this type for sure has onCreate method, or its superclass has this, right? So somewhere in the hierarchy, somebody implements this, and I'm now changing the default behavior, right? And in fact, I'm calling super, which means I'm calling onCreate on behalf of the super type, right? Here. What else? So there are two reasons. One is, which we just said. What's the second reason? So communicating to others is one. What's the second reason? For yourself. For you, it's good as well to use those annotations. So I show you. So let's say we don't have it, and I made a typo, and I called this method onCreate, and I've eaten E. The code will compile, but it would not work, right? I will have a bug in my code, which I don't obviously see, right? And now check what happens if I comment that out. It highlights red. It says to me, wait a minute, you're overriding a method onCreate from this type and from the hierarchy, but nobody implements this method. So you're doing something wrong. You have a bug, right? So it catches the bug already here, right? And then I would have to, it says here, it's a little bit small. So because I have cursor here on this red wiggle, it says method does not override method from its superclass, right? So you basically have a problem, and it's caught even before I run the code, right? So now if I check, it's like, oh yeah, I have a bug because it's called onCreate E, right? So it can catch typos in your methods. It can catch that you've used a wrong type here. It can catch that you've used the wrong type here, because all those are legitimate function calls, right? It's just that they don't override what the superclass method signature is, right? And then you will fix it before you run into trouble. So using those annotations is kind of useful, and it communicates to others, and it communicates with you what is actually happening, right? And then I am doing similar thing for, in fact, in this particular class, the only thing I'm overwriting is onCreate, right? So out of all those lifecycle methods, for the main activity, I don't store anything on pause. I don't call any of those get, set, instance state things. I only implement onCreate. I do all the logic in onCreate, and then the app is bootstrapped, and then it does what it needs to do, and I don't manage any other lifecycle methods. When do you need to implement a method? Like in here, I'm not implementing any of those methods which we discussed. I'm not implementing so I'm implementing on create, but not on start, not on resume, and so on. When do I have to implement something, and when do I not have to implement? In this case, I don't implement. I don't have to. So why is that? Yeah? No, like yes, maybe, but I'm more talking about the language, about Java. Like, what is the mechanism for forcing developers to implement something, or to let them implement or not? Yeah.
Well, if you want to force someone to implement something, you have to see interface. Because if you write implements and then the name of the interface,
that's right.
Then you have to implement
all the methods which the signatures are specified in the interface. So if app_compat, if this type was an interface, I would have to implement all the methods which that interface specifies, right?
And also you would write extends, and you would have to write
implements. Yeah, that's right. But in this case, we know it's not an interface because it's a class. It's an abstract class. And I'm extending the class. So if you want to force somebody to implement something from the base class, you have to say this method is abstract, it doesn't have an implementation, and then you have to implement it if you want to instantiate it, right? It's the same in C++. So if you have a base class which says some methods are abstract, they don't have body, they don't have implementation, then whoever is extending it and using it, they have to implement it. In this case, all the methods about the lifecycle have implementation in the base class, therefore I don't have to implement them, right? I'm actually not sure if onCreate has or does not have a base implementation in the base class. I think it has.
Because you're calling super.
Yeah, exactly. So it probably has because I'm doing that. Therefore, even that method I would not need to implement, right? None of the methods I would need to implement. All right, any questions about this? Most of the fields we use private unless we have to use something else. Some things you can use volatile if you want them to have certain properties, but we will talk about it later on. In Android, it is a common practice to prefix the names of your member variables with M, which stands for member variable, right, or member attribute. As you can see here, I'm only doing it for one, and not for the counter, and not for the text view. It's a kind of a bad practice, right? You should be consistent. You either use it consistently or you don't use it consistently, right? So you should make up your mind and you say, I'm following Android conventions and I will be prefixing all my member fields with M, or you say I won't, right? You should probably not mix it. So that's, in this particular case, it's a little bit untidy. As I told you, I always prefix things with this in code, which kind of enhances readability. And I also, everywhere I can, I use the keyword final to make the variable not being able to be changed later, right? It forces the compiler check if I'm kind of reusing a variable, and then it tells me, oh, why are you reusing the variable? Yeah?
So it's like the equivalent of const in C++?
Almost. Okay. It's a little bit confusing. So the const in C++ is more strict. So for example, if you declare something as const, the internals cannot change, right? In Java, final doesn't mean that. Final means the variable cannot be reassigned, but the the object it points to can have the state changed. So it's not constant in that respect, right? So it's kind of in between. C++ const means, you know, I cannot reassign it and the content cannot change. It's actually constant, right? But in Java, it only means that ES cannot be reassigned, right? It doesn't mean the memory which the ES points to cannot be changed. It can, and it is, because I'm doing kind of stuff with it here, right? Okay, any other questions? The other thing is we typically make every the variables which have a static nature caps, just to differentiate them from the member fields, right? But that's a convention. And everything else is camel case. We use camel case, and we use this bracketing, kind of Java style bracketing conventions, where you start the opening bracket in the line which the statement is for. You know, coming from C++, it will annoy you. You will really want to use C++ coding style. And you can, it is legal in Java. It's not like in Go, where it's like actually a compiler error. But you shouldn't, because most code and most libraries and most people code this way. So you should sort of follow the Java conventions. And then eventually you get used to it. I was coming to Java from C++, and it was annoying me initially. I prefer the other bracketing convention, but yeah, you get used to it. And then in Go, you have no choice. You have to use this. All right, so services. As we were discussing, you have graphical elements done through activity and fragments. And oh yeah, we could have checked. I'm not sure I was doing any GUI stuff with that particular code. And then we have things which happen in the background using service. What would be the, yeah, you have it here. Like you, for example, have a music player, right? So you have some UI, the user browses the tracks, the user presses the play button, and then the user will probably do something else with the phone. They will probably press a back button and want your UI to disappear, but they want the music to continue playing, right? So on the screen, a user will be presented some other activity, something not related to your app, but you want your app to continue doing something. It's the same with activity trackers. Like, for example, if you go running, you may open some activity tracker and you say, start my run, but then you will go back and pick up a music player and you want to say, start playing a music, right? And while you're interacting with the music player, you want the app to still record your run and be recording the GPS positions or whatnot, right? So anytime you have, anytime you want something to be happening, but you don't have UI for it, you will use a service, right? Can you use a service with UI? No. The service cannot have UI. Okay, so that's a pain in the ass a little bit, right? Because let's imagine you have a music player, you have tracks, you said, play me this track, and then the UI disappeared, and now the service is playing a track, right? How the user will stop the track, or how the user will make it louder or quieter if there is no UI to the service? Well, you need an activity, right? So somewhere, somehow, there has to be an activity which will talk to the service, right? And there are different ways of doing that. You can talk to the service through, for example, a database, that the activity stores something in the database and the service reads something from the database, and then the service does something. But for interactivity, that would be a bit kind of a nuisance. So there is a mechanism which is kind of called remote procedure call, which allows you to bind to the service and actually call methods on the service once you receive the instance. Why it's so complicated? Well, it is so complicated because Android needs to manage the background threads, all the threading that happens, and it isolates it, as we talked, for security reasons, into kind of boxed environments. And in fact, you can run your service completely isolated from the activities that use it, right? In such a way that a user can kill the activity, but it has no impact on the service running in behind. And you have those, especially the maps activities and so on, where you killed the activity, but the background service chews up your battery because they keep tracking your location, right? And then you have to say, kill the service, right? So the service and the activity may actually live in a completely, and they do typically, live in a completely different virtual machines. And they have to communicate over a network internally, over a networking stack, to exchange messages with each other. So a method call here is like a remote procedure call into the other service that runs on the same device, but it uses like kind of a networking stack to achieve that. So it is a little bit difficult to get it going initially, but conceptually, I hope you understand how it works, right? So you have a process which runs behind in the background, and it's isolated. And then you have another process which shows the user the UI. And now those two things need to talk to each other. Like, you cannot access variables from there because those are two different applications. They are two different like environments. It's like having two executables running at the same time. And from one executable, you're trying to access variables from the other one. Like, you cannot do that, right? So how do you communicate? Well, you have to communicate somehow, usually over the network. You open a socket here, you open a socket here, and you send some bytes between. So you unmarshal and marshal some data, and you call something, and then you send the results, and blah, 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 right? So this thing is actually managed for you. You can use the Android facilities to have those remote procedure calls done. What you can do is, and for simple things, we do a simple trick. And we have a UI with the activity, and we have a service which we make an inner class of our activity class, which means they have to live on the same virtual machine, right? Because the type and the subtype are kind of bound together. And then because they are in the same scope, in the same type, even if the user puts the activity behind, the service kind of continues to run in the background. The side effect is if the user kills the activity, it will kill the service as well. So if the user like swipes the activity to be killed, the service is killed with it, and then it's gone. The music stops playing, right? Or your activity tracker stops tracking your location. So if you require the independence of the service from the activity, then you need to do this more difficult implementation. If you just want to experiment with the background services, you can do this little trick of having the inner class of your activity, and then it will work. An activity starts the service by calling start service, and there is a call called start activity which starts the activity. You will play with it tomorrow. So we covered 2 or 3 actually biggest components: fragments, activities, and services. And now we have 2 more which we don't heavily use in this course. The other 3 you will use heavily no matter what you do. The 2 which we talk now, you may or may not use. So what often happens is you have an app, and the app needs to get some data from somewhere, right? So let's say so as an example here, we're using user contact information, right? So let's say you have an app which has user info, and it has a name of the user and email or some icon, whatnot, right? So the users kind of register, like let's say you have a friends list. You're playing some online game, and you have a friends list of who is your friend, right? As a developer, you have to manage that. So how would you represent it? Like initially, you just store your friends in memory, right? And then like the user said, okay, Frank and Joe are my friends. Then you store it, and then you have to kind of store it somehow that when the user loads the app second time, it doesn't need to say Frank and Joe are my friends. It's already remembered. So you can use a file system, right? You can store the friends in the file system, and your game grows, your game becomes more popular, and then you say, okay, I would like to have this information on the server so I can see like who is a friend of a friend, so I can recommend them that maybe they should friend them. right? So initially it was stored on the phone in the file system, but later on you want this contact information, this friends information, to be stored on the server, and you want to use a network, right? So you have to re-implement the way you're interacting with the contact information, because instead of interacting with the file, now you're interacting with the web server or of some sort of cloud service. So you need to modify your app. So what is a mechanism for us as developers using object-oriented methodologies to minimize the impact this change has on the logic of the game, of the code that you have? Well, we introduce an abstraction layer, a facade, which says the app interacts with this interface, it reads friends and writes friends, and it doesn't need to know how it is implemented. It can be implemented as a file, or it can be implemented as a network call to a cloud service, right? And that's exactly what content provider is. Content provider is like a thin layer which uses SQL-like semantics for storing and reading data. And the backend can be local file system, can be local database, can be remote database, can be remote cloud service, whatnot. It can be anything. It is invisible to the app because the app interacts with the functionality using the content provider, right? So in practice, if you have a situation which is kind of a data-driven and you want to isolate the logic of your application from the way the data is actually stored, you know, for persistence, you can use a content provider. When do you use content providers elsewhere? You use them where they are available. So for example, they are available for the system contact info. You interact with this using the content provider interface. You can query what contacts the user has on the phone and so on. And you use the content provider mechanism to achieve that. And you don't care how Android is storing that. Is Android storing it in the local file system, or is this stored on Google Cloud and read from the Google Cloud, right? All you see is this kind of a content provider interface to reading contact information for the given user. Is that clear? Make sense? I think it kind of makes sense. So then we have the final thing, and the final thing is interesting, and you will use it you will not use it heavily, but you will use it. We will have one lab which requires you to do that. What is this? So let's say you have a music player. As we were saying, you open the app, you pick the track, and you say play, and then you go back button and you start your running tracker, right? And you are running, and you say have a running tracker on top as an activity. How would you stop the music? Well, you can stop the music by relaunching the app, right? Finding of your app and relaunching it, and then interacting with the service through the activity that you had before. But then you have to remember that you have to remember which activity was responsible for which service. So with music, it's a little bit okay because the music is playing and you hear the music playing through headphones or through the speakers, and you remember that, okay, the music is playing all the time. But let's say you started the activity tracker first, which started logging your GPS locations, and then you went to the music player or whatever, and then now you want to stop the run. And you forgot that you were running or something, right? So the user interface should communicate to you that there is something happening in the background, and how they do that. How is, yeah?
For music players, it's like take over your lock screen and show the lock screen.
That's right. That's right. So you have those kind of it's a little bit more complex than just taking over the lock screen. The lock screen is still there. It's just that on modern Android, you can show notifications as kind of a more rich UI components, which are shown on the lock screen. So you have your music player there, you have your email notifications there, whatever you want, like you can customize it, right? So we do that through notifications. We have the mechanism for notification to be visible, even if the UI is not visible. And then when you click on the notification, it kind of relaunches some activity that is responsible for talking to the service, right? And the mechanism for doing that is broadcasts. When do you need broadcasts elsewhere? Let's say your phone is running low on battery, and as an app developer, you don't want, like, a user is running, you logging the points, the GPS points, the phone is about to shut down because they're running out of battery, and you want to know when the phone will shut down so you can save all the data into a file so the user doesn't lose it, right? Or the user is typing an email and the Android says, I'm gonna kill this app right now, right? And you say, okay, just give me a second, I just want to store it so the user will not lose the data, right? And those things are actually happening through broadcasts. So the operating system, when they do something, they will broadcast like, we are about to run out of battery, we are about to shut down the phone, we are about to run out of RAM, we're gonna start killing applications because, you know, a user wants this game now and we don't have any available RAM, so we're gonna kill all the other apps which are occupying RAM to remove some of the space, release some of the space. So you have some system broadcasts which happen, and then a broadcast receiver is like you declaring that you're interested in a particular broadcast, right? So a broadcast receiver is a mechanism for you to register your activity, saying this activity is interested in hearing about those broadcasts, and then there is a mechanism to notify them when the broadcast happen, right? So a broadcast receiver is a kind of an implementation for being notified about stuff that happens on the phone. Yeah, we have some examples of events that I already talked about, and then as I was when I started, I talked a little bit about these notification things, because you cannot have interface for broadcast receivers neither. So a broadcast receiver is something that has no UI, but you can kind of create a notification upon receiving the broadcast, right? So you can create a kind of a status bar notifications to let the user know what actually is happening, right? So for example, if you implemented a broadcast receiver which will save your data when the phone is about to shut down, what you can do is you can save the state and then create a notification saying, we saved your data, like your data has been backed up, right? And that's a notification. That's not a proper UI, but it's kind of like a UI mechanism to tell the user that something happened. Make sense? Yep. You have to make a receiver for every single broadcast that you're interested in. But typically, if you have your app, and your app is composed of multiple activities, then it's just one for all of them, right? One receiver for all of the activities inside the app. Yeah. How are we doing with time? We doing well. So we already talked about it, that your activity can launch any other activity. So for example, you have some social app or some running app and you need to allow user to take a photo. Do you have to implement the camera capture stuff? No, you don't. You can reuse the built-in camera to capture the image, and that's what your expectation is. Like usually you kind of capturing images using the things that you have already on the phone, right? So photo capturing or browsing something, you can open a browser, you can open anything that is on the phone for the user and interact with it. And kind of, so what happens is, let's say you have a running app, you say take a photo, you have the photo taking app, you took the photo, this app kind of disappears after the photo is taken, and you go back to your app, right? So it feels like if it's part of your app, right? Because you're kind of in and out of your own activity, right? That has not been the case on iOS. On iOS, you cannot have kind of activities. They don't have activity concept, but it is kind of similar. It's called view. You cannot have views which are like, this view is from my app, this view is from somebody else's app, and this view is from my app, right? You were not allowed to have that. You have to have my view, my view, my view. I'm not visible. Somebody's view, somebody's view, somebody's view, right? On Android, it's very easy to mix somebody's code, your code, and so on. There is no entry point, so I already talked about it earlier, that on Android, any activity can be launched. You specify in the manifest which ones are launchable, but in theory, any activity which has a visible element can be launched by the user, right? And it's common practice for an app to only have one launchable activity, which is your main screen. But sometimes you install an app and it has two. Like I had a couple of cases where I have the main app having one icon and having like a backup as a separate activity that is launched separately. And then on home screen, if you install the app, you have two icons suddenly, right? One for the main app functionality and one for something else. You can have multiple entry points to your app. And there is no main function in Android. Like nowhere in my code for the example I gave you, there was a main function, right? Does it make sense to have a main function in your activity? So like would it be legal for me to have a main function in my main activity? Yep, no problem. You can have a main function. Why would I have a main function here? Yeah. No, because this main function would never be used by anything or called by anything. It's not an entry point to anything. But I can have a main function and I can call it. I can say Java, whatever the package is, com.imt3673.threadingdemo.mainActivity and run it and have something in a console to be tested, right? I can run it on my PC to test some function which doesn't use Android functionality just to make sure that I'm doing my Java stuff correctly, right? If you're converting like hex to binary or binary to hex or something, and you want to have a little test and not use JUnit, you can write those tests in the main function and then run them by calling the main function in the console, right? So not using any UI, not using any Android stuff, just testing some of the logic, some of the functions. But typically you don't do that. Like I don't have any main function here, but it would be fine. And sometimes I do for testing, like temporarily. All right, so we went through, as I expected, through the elements. There is a little bit of background for the structure of the Android, and there is still a little bit of details of how you start an activity in code, because we didn't talk about it today. You have to call a method start activity, but you have to pass it an intent. And we haven't talked a lot about the intents. So some of the kind of the things Martin will talk with you tomorrow. And what you will do is you will create a simple hello world with more than one activity and kind of see how the switching between the activities work, right? Questions? Great. So thank you very much.
One
Yep.
kind of semi-relation.
Okay.
How it's like in game loop, if you don't have a function, you just throw it in like an activity or something.
Say it again.
A game loop, like the just the do while run the bangs.
Yeah. So in the game loop, what will happen is you will have a main activity, which in the manifest file you say that's my main activity, and then what will happen is on create will happen. And in one of those methods in your lifecycle, you keep the thread busy, right? So I will show you here. So in onCreate, typically, what you will do, you will capture the UI thread, and you will have a loop which keeps being looped over all the time, right? And then you may need to check if you're being kind of paused right? So like in onCreate you kind of have it. On create or on resume, you have a loop, but the loop every iteration it checks are we still visible or are we not visible anymore, and you will know it because if you're not visible anymore you will be on pause. So then if you're not visible anymore you have to like quit doing what you're doing because there is no point anymore, right? Yeah.